Hi, welcome to this platform for Sensor Academy, either the YouTube channel or the Facebook page. If you're watching this on our YouTube channel and that it is your first time, consider subscribing, turn on the notification bell in order to get notified when next I post any video. If you're watching this on our Facebook page, kindly leave a comment, share the video, and make sure you tag that grade 12 candidate that may find this same video very much beneficial, either for an exam video preparation or revision. In today's tutorial, we're going to consider physics as usual. This is going to be a part of science paper 1. We're going to focus on a topic called electricity, and the question that is from B7, which is from section B. It says figure B7.1 shows resistors connected to a 4 volts power supply. When we talk about a resistor, we're trying to talk about a device that measures the amount of resistance inside the circuit, and resistance is defined as the opposition to the flow of current in an electric circuit. So we have a 3 ohm resistor, we have a 6 ohm resistor, and a 12 ohm resistor, and of course this is a battery. So it says, what is the effective resistance of the circuit? So we can observe that this 3 ohm resistor, this one is in series because it's in a straight line. But 6 and 12 ohms are in parallel. So what we are going to do is, we can name this as R1, then we can name this as R2, we can name this as R3. So we are going to find a combined resistance between these two, then add to the 3 ohms. So we're going to say the total resistance is going to be R1. This one is in series, so we're going to add. Then these two are in parallel, so we're going to say 6 times 12. Again, we divide 6 plus 12. So this one is going to be R2 multiplied by R3, then everything over R2 plus, that is R3. This only applies if 2 resistors are in parallel and the other one is in series. So for these that are in parallel, if at all we didn't have the one that is in series, we would have just multiplied and added in this way. Then we're now going to substitute. Well, we're going to say R1 is going to be 3 ohm, and then plus, then R2. R2 is going to be 6 ohm. Of course, you can put the brackets. So 6 ohm multiplied by 12 ohms. Then we're now going to say 6 ohms, then plus, that is 12 ohms. So we're now going to say this is now going to be equal to 3 ohm plus 6 times 2. We're now going to get, that is a 12, carry 1, 6 times this one. So we're now going to get a 7. So 72 ohms squared over 6 plus that is a 12. We're going to get that is 18 ohms. So total resistance is now going to be a 3 ohm and then plus. If we can rightly observe, we're going to find that 18 here, it's a 1. 18 there, it's going to be a 4. So this one becomes 4. Then we cancel ohm and ohm, so we're going to remain with this ohm. So total resistance in the circuit is now going to be 7 ohms. So since this one was in series, we have to firstly multiply this and add using the same. So it said 6 times 12, it's 72, over 6 plus 12, which is going to be 18. 18 into 72 is now going to be 4 ohms. So total resistance is 70 ohms. Then B, calculates the potential difference across the 3 ohm resistor. Potential difference is the other way around of trying to be asked what is the value for voltage. So we're now going to say voltage equals to current multiplied by resistance. And of course, on our right, we're going to come up with our data. We're going to say V, which is the potential difference, we don't have. Then I, which is the current, since they're saying calculate the potential difference across the 3 ohm resistor. We want to see if at all these 4 volts that we currently have here can be used to find here. So here we're going to put this one. Then on the resistor, we're going to put this one. And whenever we're talking about current in series is going to be the same. and voltage in parallel is going to be the same. So voltage between 6 and 12 is going to be the same, but the voltage that is going to pass through, that is this 3 ohms, is going to be different. So we can calculate for the current. So I'm going to calculate for the current in the circuit, which is voltage over resistance. So the voltage in this instance is 4 volts. So here we're going to say 4 volts over. Then the total resistance here is 7 amps. So the voltage here is going to be 4. The current here is going to be 4 over 7 amps. So you can say voltage equals the current is going to be 4 over 7 multiplied by, then the resistor which we're talking about is a 3 ohm. So here you can say amps multiplied by 3 ohms. So voltage is now going to be over 1. 4 times 3, we're now going to get, that is 12 over 7, which when simplified, we can say 7 into 12 is going to simply give us 1. Remember, that is 5 over 7. Then we say volts. So this is the answer for the voltage, which is going to be given as current multiplied by resistance. So the resistor is 3 ohm. Now the thing is, the 3 ohm here is in series, so the voltage is going to differ. Hence, we don't have the current. So we can firstly start by finding the current, which is current equals to voltage over resistance. So the total voltage is 4 volts. Then the total, that is resistance, is 7 ohms. So this is a 4 over 7 amps. And then voltage equals to I times R, where there is the current, we say 4 over 7 amps multiplied by 3 ohms. We say it over 1. Then 4 times 3, it's a 12. 7 times 1, it's a 7. Then 7 into 12, it's 1. Remember 5 over 7. And the correct units are volts. So this is how the question in physics, particularly Science P1, came under electricity, hoping that at least you can pick it up from how the formulas are being stated and how the calculations are being done. Also fully understanding that potential difference is simply able to mean the voltage. So in the final answer here, you can say 5 over 7 volts. Like that. So having to do so, I believe this is going to help out in terms of any exam preparation that relates to electricity. I'm hoping that you subscribe to this YouTube channel and turning on the notification bell, also sharing the video. Till in the next video, for now, it's a very goodbye. Stay focused.